Excellent. Hey, so I'm just going to make this video for GD&T Problem 4. Still back in week 6. I lost this video when we did it live, so I'll kind of fast track streamline it just a little bit. So it is Problem 4, and it is a slotted block here. Let's see, like that. Same scenario. I'm just going to kind of think critically of what's on this and see if there's some cleanup that needs to be done when I take it to Inventor. Um, and then we'll do a drawing for it. So I'll just kind of fast track where I'm at. I just use this to get my part modeled in space. I'll actually go to my PDF and there it is. There's the PDF of mine, a little bit larger, so we can see it. And so, even just to start the modeling, what I had to consider is just take a quick look at the dimensions. And I've got some that are limit size dimensions. They're displayed as limits, right? The upper and lower value. So when I got into that scenario, which was really to, we'll go check my drawing, but I think I drew this shape and then extruded it this 3 inches long. I think I just drew this shape in the right side view on the right side view plane, and so when I what I was talking about in class is when if I'm recreating a model that has and I'm working from a drawing like this. Really, I have three options. Yeah, I say I kind of have three options to determine, like, because I'm going to have to constrain this in my sketch. So I'm going to have to know a dimension. I can't constrain it as a limit necessarily. Probably if I dug into that, I could. But if I'm just going to constrain it with a single dimensional value, I could choose either of these. I could choose the lower limit and have my model at the lower limit, as kind of its actual size as I model, or I could have it the upper limit and model that way. Or I could, I think what I generally go for is I'm going to model at the median of this here. So, um, what 2 to 5 is 3 thousandths, and so I would add 1.5 thousandths to the lower dimension, or subtract 1.5 thousandths from the upper dimension to kind of get what the median dimension is in there. So if I took this, and I modeled mine at the middle between the limits. And it's not to say that that limit is necessarily, they're kind of weird because they don't have like a dimension and then a plus or minus on them. That's already kind of factored into them. And so, you could display that dimension as a dimension plus or minus, 1.5 thousandths or something. What I'm just showing you is even just to model, I need to pick a dimension, you know, worst choice is not to pick anything. The best choice is to pick the right dimension, and the next best choice is to pick the wrong dimension and figure it out later. But that's why the way we constrain our sketches, we can get in and manipulate them. Uh, so this isn't have to. I don't have to necessarily design this perfectly. I can always come back to it. But for me, I'm just going to model to the median point. So if we have like a dimension like 405 at the upper end of that limit dimension, I'm just going to subtract half the distance to get to the lower dimension, which it's 3 thousandths overall between the two limit dimensions. So I'm just going to subtract half of that. So that would be a subtract point as 0.0015. That's 1.5 thousandths. Yeah. If I was just talking about it shorthand, 1.5 thousandths. No, it's confusing, but this is what I'm subtracting from that dimension. That equals what? 0.4035. So I'm actually modeling that dimension at 0.4035. So if I'm gonna jump quick to my model here, and so what I've done, ahead of the game is I've already done the modeling for this before I'm really jumping into this video. I just want to talk about a couple little attributes of that, working from a drawing like we are working from, and what I chose to model this at. Other than that, I've just placed, some general center lines and pull these together for sure. And likely my dimensions will come out this way, but I can wait for that until I decide the dimension. But I've just done my overall dimensions first. That's it. And then I've kind of stopped. If I go to the part and let's just look at my sketch. Yeah, there was the original sketch. It looks like I extruded it, across the center line. So here was the original sketch. Everything as kind of displayed, except for this is that oddball dimension. It doesn't look right because it's rounding to 3 decimal places. If I can go in here and take a look at what I really entered in. So I don't think we've talked about this too much, but the display value of these in your sketch are controllable as well. Like it's I haven't changed this ever at all. This is just three decimal place is what I think default sketch dimensioning is, at least the display value. I think you're really drawing to a higher degree, but it's just choosing to display three decimals only in the sketch. It's definitely editable, and yeah, I can do an item. I can localize an edit here too. So if I just like I think right click on this and go to dimension properties. So I'm not even selecting it. I think either way though, you can either select it. Yeah, I can either left click and right click to get this dimension properties. And then you're in this where it is showing, oh, here's the value. I'm actually only displaying three decimals of that. That's why it's 404. But I really did type in 0.4035, just like I figured here as my dimension to put that in. And it would display, like I can change this precision even within my sketch. And there's what I actually displayed at. Um, and so this is technically easier to get in and manipulate once I can identify, oh, actually I'm holding four decimal places, or I can just see that that's what that real value is, that median point between those limits. That's just a place to start dimensioning this. I'm going to manipulate that dimension on my drawing to display correctly, maybe what I inherited. There's no reason why I could just keep the limit dimension. So I just need to pick a model value there. That's what I've done there. And then I've extruded that length. And then it looks like I came in and did this secondary sketch, which whether you do that from the bottom surface or the top surface, I think is probably fine. I mean, maybe somebody would argue that the bottom surface might be the better place to sketch that because that is a datum. And this technically this inner surface that I've chosen to sketch on is actually no datum. We're getting into particulars there, but it is good thought process. So let me just go into edit this sketch. And so I've done a couple different things. Like I definitely have projected kind of this side, this little edge here, and this edge. So I've projected, I think I just projected that surface and had the whole rectangular projections that I just turned to construction lines because I was just dimensioning from them is all I'm doing. And I added the two circles at their value. Let me just check my print real quick. So I added the circles. They were also displayed as a limit value. And what I didn't love about this print is that there is no GD&T going on here. It's like we have the assumption of GD&T because we have basic dimensions coming that have been identified clearly for the hole locations, yet the hole itself is not being dimensionally controlled. So you mean that might be fine, and that might I'm going to place some positional geometric controls on this. At least that's what I think I did. When I did this in class the first time, let me just take a look at my print that I did in class when the video didn't recover. Yes, I decided to say, so I changed this a little bit. Something that is GD&T controlled, and then it makes a little more sense with my basic dimensions. And I've also changed those up a little bit. So let me go back to what I'm looking at here. So this is like a 1,000th. I think what did I do? I just changed this to 0.56, and then I kept the value of plus or minus 5,000ths that's implied by the drawing. So let me just double check that on my. Yeah, that's essentially that was one change I made from that drawing. I just didn't love that I wanted to keep it along the lines of what we've been doing and not throwing all different curveballs here or there. So I wanted this to change to more of a basic position GD&T control. So I've chosen to make these at 0.56, and then I've added I don't want this hole size to get any smaller than that, but I will allow it to go above at 5,000ths. And so it's kind of it's a bilateral, no, 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 unilateral. It just goes one way, right? One direction from 0 to plus 5, plus 5,000ths. So, and so I'm going to change that dimension to be something that's a little bit more in the scope of GD&T, and then I'll associate those dimensions, basic dimensions with that. And so some of my dimensioning changes from that because what I had identified on this back to this drawing, not only am I going to change this, but I'm gonna model at 0.506 for those circles. That's really where I'm trying to figure out back to my model. I'm going to model those at 0.56, and then I'm going to apply the tolerance It's not exactly, it is different tolerance because I'm only going in one direction. I'm not allowing the dimension to go in both directions like the general tolerance would allow. So I'm controlling that a little bit different than the general tolerance. And but long story short, the other thing I didn't love about that is this dimension. And so if I just and because it's not pulled from a datum, right? Like let's see, our datum A is bottom of front surface, and I'm controlling it. And I've opened up these controls to be a little coarser, right? So I'm going back to 10,000s here on this. So I'm going to apply this control to this surface that is datum A, this feature with this feature with this datum feature symbol identifying uh, the datum feature, and the feature is the bottom surface. Excellent. And so these are fine. Then B happened to be maybe a different datum than we might be expecting, but it's going to be this inside surface of the slot. We're going to establish that as datum B. And so, and then additionally, we don't have a datum C. So that's the other issue I came across here is, and really what helped me identify that was just that they're pulling basic symbols from a non-established datum or basic dimensions from a non-established feature. And so I then made the decision to say this is datum C, this left side surface, and that will let these be basic dimensions from a datum C. This one is pulling from the front side surface, which I still is not a datum. And so B is a datum. And so I chose to pull this dimension from that datum to this position in this direction. And so that's changed on my drawing. And so we'll get into that when I go to do it. For sure, I've identified that. Oh, and the slot width, this I guess before I even move on to that hole, which I kind of already had. When I dimensioned the slot width, I don't even think I put this dimension in my sketch, right? I think I just did 0.5 on each side, and I think that adds up to be, I'm allowing this to have a limit from 7.5 to 7.512. This whole thing is what, 1.75? So what I was just looking to say is 1.75 on the overall depth of the part minus I think 0.5 on each edge, you know. And so that ends up being that 3/4 would be the if this was modeled at 1.75 in depth, then and a half here and a half here, that would drive the dimension to being 0.75 in between. However, I'm letting that uh, be a little variable with a limit dimension, no less than 7.5, but up to 712, 0.7512. Um, that makes me think that the half-inch dimensions are going to be the ones that are kind of driven. So, and I'm not really controlling those dimensions either, other than just the basic tolerance control. And so I'm going to let this potential, because datum B is a surface that I'm controlling, and then I need the next surface over there to be parallel. I am controlling this next surface over. I need it to be parallel within 2000s. I may have opened this up to 10. I'll look at my model. And then from datum B. So I'm keeping this like I'm like establishing two parallel planes on either side of that theoretically, well, that limit type dimension. It's not a basic, so it's not theoretically exact. It's like whatever my limit engine, whatever my in between, as long as my dimension is lives within these limits, whatever that is, once that's established that, yep, it lives in those somewhere, it's, somewhere between 0.750 and 0.7512, then it also has to additionally fall within two planes on either side of that are, in this case, 2 thousandths apart. I've probably opened it up to 10 thousandths apart. Um, and as long as and that's the other controlling feature. So I've got this limit that I can work with, and then I've got to control that parallelism of this other feature from datum B. And so that's what's going on here. The 0.5 dimension is maybe going to be the victim of circumstance and become less than 5. And it's like fine with me, potentially, as long as I don't fall outside of what the general tolerances allow it to be plus or minus 5 thousandths. If I had cause a clash with that, I might have to reevaluate my GD&T controls and see if I can uh, figure out a better displayed settings or what's going to work the best. So that's my little like my synopsis of how I drew. Let me go back to this, how I drew those parts. and why I'm choosing to put in these particular constraint dimensions. I'm from my datum C now that I'm going to say needed, and I'm from datum B. And then so this, when I get into my part sketch, it kind of resembles the way I'm controlling it on the drawing. And so it's not something that's like, this is just me thinking where I'm, where I want to end up and kind of choosing the path to get there, right? And so I kind of know where I want to go end up, and I've recognized some issues with previous files, GD&T. So can I correct this a little bit? And then, if I'm working from the drawing, but then I jump into the part to make some corrections, it's not like I'm jumping into a sketch that's totally foreign to me and pulling from all different directions, right? It's like I should probably, really analyze the way I'm even sketching GD&T control parts, just so that I'm not like, using different data to hit the same locations. I really think of my sketch as driving from those datums as well. And that's why I've chosen to sketch this way. And great. So I'm going to say finish that, put my two holes in it. And it was basically done. And then I was ready to throw this on a paper, and I did. Here it is. And I've got some general dimensions on it. And now let's just finish kind of doing the general dimensions, maybe the features of size. Um, I've got the overall features dimensioned, kind of. This is kind of a feature here, right? How far this is could be considered a feature of size, but I think we're not really controlling this dimension other than a limit dimension. So I'm going to say dimension this thing from here to here is going to be a dimension I'm going to need. Um, but I need it to display as a limit. And so if I that's an option here. Just one of the, kind of preloaded default styles that I can just choose from here. Of course, I'm really working manual here because I haven't really outlined, I could just select a dimension style and build one. I'm still using, just working really manual, really localized changes here because our prints are small for the most part, and because the changes I make are you know, I'm not dealing with hundreds of sheets to change. That would absolutely require me to set up a dimension style, so I don't have to do this on every sheet of hundreds of sheets. But right now, so I'm kind of just doing it, and I think it's good to see the manual aspect, and then we can worry about like formatting it to do this for us and apply those formats to my dimensions, just like I would in CAD with a dimension style. So this is limits stacked. Limits linear would be taking up more room that way. So I'm gonna do limits stacked. And just my upper, I can say, well, let's display these primary values. I think we're just holding 3 decimal places. So if I change my primary unit to 3 decimals, um, then my, uh, um, what am I trying to say? Then I usually change my tolerance to match that, right? Tolerance values match kind of the dimensional values that they're assigned to. Okay. But this is not, I'm actually wanting this to be on the upper. I'm just going to match my drawing now. It's 405 to 402, right? So I'm just going to set that in as my upper lower, even though I'm modeled at 4035. Except what I want to display is 405 on the upper, acceptable dimension to 402. And I'm going to say, okay. And so then I've got that limit value showing with a modeled value as the median. And I'll do the same thing. So that's that way, I've got that height, the overall width. Now I'm ready to move to the slot, I think. I'll move to the slot features, which could be considered a feature of size. We're at least considering this a feature surface to apply a datum to. But I can just do the dimensions from for it. And so I'm going to say, well, the slot's going to be dimensioned from here to here. I'm going to control the parallelism, but I'm also going to control this dimension, not with GD&T, but with limits. And so um, I'll just set it up as its own limits stacked. And I'm going to display 3 decimal places, right? And if I ever do tolerance it'll be to 3 decimal places. So there's what it is, because I've modeled it 750. And then I just need to know that the the permissible dimensions were 7512. They were actually out to 4 decimal places. So I need to kick this one out one more, huh? Yeah, so it was a unique dimension on the sheet that we were controlling 4 decimal places while everything else is being controlled by 3 decimal places. So I'll factor that in. I'll say, oh, I want to display 4 values. from 7.5 to 7.12 and say, okay. So, and then the last one we needed was, it's kind of a chain dimension because, the way I view this one is it's datum B to here within those limits. Watch the parallelism when we apply it. And then over from there to this 0.5 inches. So this isn't coming from here, there. This front side surface is not even a datum. So there's there's kind of like, I feel like kind of size and locating dimensions for the slot. And then let's do size and locating for the circle. And I don't know where I ended up, looks like I ended up dropping my little GD&T for the circle there. So I'll plan on that again. I just need to dimension it first. Here's the dimension for the circle. We modeled it at 0.560, so this is correct. It's going to go out to 3 decimal places. Yeah. Maybe I'll take care of this one too, and the primary tolerance will be 3. There's 2 of these holes, so I think I'll take care of that in here. I need 2 of these. And additionally, I decided I'm going to do it. I'm going to control it. I'm going to control the position of this hole better than the previous print did. By better, I just mean maybe better defined. Not necessarily better, but better defined. And so what I want it to display is the tolerance, um, whether they're symmetric or deviation type tolerance. And so I think this was a deviation tolerance oh, sorry, not that one. Let's see, this one. I think it's a deviation. I'll just set it first. So I've got a deviation, and the upper limit I was allowing to deviate 5 thousandths, right? But I didn't want the hole to get any smaller. So this seems correct to me as the way I wanted to display that before, even just before we're still in just plus or minus values here, and the dimensions that I'll apply for the location will just be plus and minus kind of inferred. And then we'll kind of like not let that be the case, and then we'll apply our GD&T symbols next. So at least I've got it to that stage, and I'll leave it there, and then I'll locate it, and I'll come back to the GD&T. So I'm just going to locate it real quick from a datum. So this is a datum locator dimension. That's surface B. I haven't showed it yet, but I know it in my head from the drawings, and I will like pull this out to meet my extension line. Um, let's see, and then I'm going to control these positions from here to here. I'm going to chain these together, even though normally we would probably do if we weren't doing geometric controls on those positions, we would likely do a baseline dimension here, right? We would like to pull both those positions from this left side surface and not allow a tolerance stack up to start occurring, right? Like if I'm not geometrically GD&T controlling the position location of these, then and I don't have any other additional plus or minus values, then what's going to happen is these dimensions are going to assume this type of control on their size and location. And the more of those things I chain together with that type of dimensioning style, the more tolerance stack up could occur and cause a rejection of part just due to things being, the tolerance eventually I would break the threshold. Like at the first couple, I might still be within tolerance. Remember, it would be like targeting a rectangular tolerance zone for a round feature of size. And so I would eventually probably the third, I don't know how ready. It depends on how far off you are one way or the other in your tolerance acceptance before the tolerance stack up occurs and starts cascading things that are out of tolerance. Um, so I wouldn't dimension this way if they weren't going to become basic dimensions. I would then generally then prefer a baseline type dimensioning to prevent tolerance stack up. Okay. Location, size. So I feel like I feel like I'm dimensioned like how we would normally maybe have stopped in some previous drawings, but now I need to apply GD&T to this. So let's do the datums. So the next thing I think of is where are my datums? My datums are bottom surface A, right? So I'll place that one. I'll let it be A. I'll move on for a minute. Datum A, bottom surface bottom of front surface. Let me just minimize this, get rid of that for a minute. Yeah, datum A, and I'm also controlling that with some control, some flatness control that I'm going to push out to 10,000. So I can apply that too. Um, and I can apply them separately like this. This is me like kind of like feeling like GD&T 101 where I'm like, I'll just do them separately because if I hook them together, do I wonder if I'm doing applying like a plane or an axis? You just have to be careful, right? When you start stacking datum feature symbols onto feature control frames, could we misstate this? And yeah, we could. We could potentially. This is kind of like a hard to misinterpret, right? It's datum A, and then I've got this other flatness control. I can apply form controls like flatness, straightness, without it necessarily being a datum too. Like that can be just something that I geometrically control a feature of this particular part with its own form control, regardless if it's not a datum or not. This one just happens to be a datum feature, and I've got my datum feature symbol on there, and then I'm additionally kind of just controlling its flatness, which is common. And I think we find in Inventor it wants to automatically apply that you're going to if you're going to establish a datum in Inventor as a what we'd call is model-based definition and do all my annotations on the model. I think its default is to apply some form control on whatever feature you're. Yeah. Hey, what's going on?